For 1993, Chrysler introduces 3 vehicles that are among the finest passenger cars we've ever produced. The Chrysler Concorde, an upmarket luxury sports sedan for the upscale buyer. The Dodge Intrepid, a sophisticated performance car for the midsize sedan buyer. And the Eagle Vision, a Euro sedan for the import-oriented buyer. The Concorde Intrepid and Vision use a new cab-forward design, which moves the front and rear wheels toward the corners of the vehicle, resulting in a wider track, longer wheelbase, and more interior room for a car of its size. The Concorde Intrepid and Vision were developed using the CATIA design system, a computer-based system that results in high levels of precision in design and engineering. The Concorde, Intrepid, and Vision are built at the Bramalea, Ontario assembly plant. Its facilities and equipment are state-of-the-art, and the workforce is skilled and motivated to put together a quality product. Before being painted, the Concorde, Intrepid, and Vision unibody is washed and treated. It is then covered with 2 types of primer, 2 to 3 color coats, and 2 clear coats. Here we see robots applying paint to door frames and inner panels. When the chassis is assembled, it is robotically lifted up and bolted into the upper unibody. The windshield and backlight are installed using a completely automated procedure, which ensures a quality fit. Doors are removed after painting to make interior installation easier for assemblers. Each car line uses a different front bumper and fascia design. The headlamps are unique by car line, and the hoods have different contour lines. The front fenders, body side moldings, cladding, and design of the rear quarters give each vehicle a distinctive look. Rear fascias, taillight lens design, and deck lids complete each vehicle's individual identity. That's the story behind the new Concorde, Intrepid, and Vision. For technical information on these great vehicles, let's move to training headquarters.
Welcome to the Concorde Intrepid and Vision Technical Training.
This is the first program of 6 that will take you through features, systems, and components that make the Concorde, Intrepid, and Vision some of the best ever produced by Chrysler. This program presents a technical overview. The other 5 will go into more detail. They are
Steering, suspension, and brakes, restraint systems, the 42LE Transaxle, the 3.5-liter engine, and the 3.5-liter fuel and ignition systems. Hi, I'm Chuck.
And I'm Kim, and we'll be providing the training for these exciting new vehicles.
The Concorde Intrepid and Vision have been aerodynamically rated with a .31 coefficient of drag. Contributing to its aerodynamics is the steeply raked windshield, which reduces wind noise and is chemically formulated to decrease the transmission of ultraviolet and infrared rays. The front fenders are made out of composite plastic called DuPont Bexloy 550. They're lighter than sheet metal and corrosion and dent resistant. Repair procedures are provided in the service manual. The bumpers are a closed box beam design using ultra-high-strength rolled steel. The front fascias are designed to easily snap onto the bumper system, and 2 different fascia materials are used. Intrepid uses thermoplastic fascias. The Vision and Concorde fascias use reaction-injected molded urethane. Special repair procedures for these materials are provided in the service manual. Fog lamps integrated into the lower front fascias are standard on Intrepid ES and Vision TSI. Headlamps, unique by car line, are all aero-type units made from high-impact plastic with a scratch-resistant coating. Could you pop the hood latch, Kim? By the way, the hood is unlatched with a lever on the floor between the sill and the driver's seat. These headlamps use a bubble leveling system, which lets the customer adjust the headlamps up and down to allow for ride height changes. The headlamp bulbs are halogen type, and they're replaced by removing 2 screws at the top of the headlamp, one here and one here, then removing the headlamp. The bulb can then be removed from the headlamp. Remember, they're halogen, so don't touch the bulb itself with bare hands because the oil on your hands causes them to burn out prematurely. The park turn signal lamps are also unique by car line, and the bulb can be replaced by simply releasing a latch and removing the lamp. The hood lifting mechanism is also new. 2 gas-filled struts are used to hold the hood in the up position, but the struts are not interchangeable between car lines because of their different lift capacity.
2 types of outside remote-controlled mirrors are available. A fold-away mirror, which is heated and electric, and a fixed mirror on the Intrepid only. The wipers use what is called a wet arm system. 2 nozzles are located right on the wiper arm. The left blade is 22 inches, the right blade is 24 inches, and they're 8-point blades, which make better contact with the windshield. Wiper speed is tied to vehicle speed during intermittent operation, moving slower below 15 miles per hour and faster above. This is controlled by the body control module, and the wiper relay is located in the power distribution center in the engine compartment, eliminating the clicking noise in the passenger compartment.
Tail lamp lenses are also unique by car line, but the wiring is similar and separated by function. The Intrepid uses a full-width tail lamp design. The Concorde also uses a full-width design. The Vision uses a 5-function 3-color Euro design with an amber turn signal lens. The deck lid uses a newly designed hinge called a gooseneck hinge. The hinge is designed with torsion bars that are easy to adjust and make the trunk lid easy to open and close. On some models, the lock cylinder is off-center and the latch is operated by a cable. The deck lid latch also has an electric remote release in the glove box on all but the base Intrepid. Oh, and one more thing. The radio amplifier is located in the trunk on the driver's side.
There are many new features in the doors. First of all, they have full double door seals. One seal fixed to the body, another seal fixed to the door. There's also a 3rd seal above the belt line. The inner door panel design is really unique. Let's take a closer look by removing the door trim panel. First, remove the speaker grill using a trim stick. Then, remove the 6 screws holding the door panel on. 2 are behind the speaker grill, 1 is behind the door handle, 1 is inside the pull cup, and the other 2 are at the front and rear corners of the door panel. Before removing the door panel, remove the pull cup. For vehicles with manual windows, you'll have to remove the window regulator handle. This is done by releasing a spring clip that holds the handle on. This special tool is available from Snap-on Tool Company. Hook retainers are used to hold the door panel in place instead of the push-in clips you are familiar with, so door panel removal is different. To remove the door panel, pull the trim panel in at the top rear and push up at the bottom rear. Repeat this at the front. Next, disconnect the latch release rod attached to the door handle. The door panel can now be pulled away from the door. Notice, first of all, the wiring is mounted on the back side of the door trim panel instead of inside the door. This eliminates electrical failures due to chafed wire where it enters the door. The water seal mounted to the trim panel can be removed and reattached to service the trim panel. The window regulator mechanism is a new design, and the regulator bolts and mechanism are located on the inboard side of the door instead of inside the door. We've talked about the exterior and the doors. Now Chuck will show you the interior features.
The interiors of the Concorde Intrepid and Vision were developed with extensive research into ergonomics and safety. All controls and switches can be easily reached, and there are LED readouts on the accessories that can be read at night. The instrument panel is designed for safety. All surfaces are softened and radiused, and all protrusions are rounded. The instrument panel is covered in a soft-touch plastisol material that provides a rich, non-shiny look. Only cleaners that enhance this look should be used. Let's go inside and take a closer look. The instrument cluster includes 9 indicator lamps, 4 gauges, the shift indicator, and the odometer. The cruise control switches are located on the steering wheel. There are 2 overhead consoles available. The full console on vehicles with bucket seats comes with dual reading lamps, courtesy lamps, storage for sunglasses and garage door opener, and the overhead travel information system. A mini console on vehicles with 50-50 bench seats provides dual reading lamps, courtesy lamps, and the overhead travel information system. The overhead travel information system provides the vehicle compass, outdoor temperature, instantaneous fuel economy, trip odometer, elapsed ignition on time, average fuel economy, and distance to empty. The seat belts on the Concorde, Intrepid, and Vision are 3-point active belts outboard and 2-point active belts for center passengers. The driver and passenger belts have an adjustable turning loop on the upper portion of the B-pillar that changes the position of the seatbelt webbing anchor point to 5 different positions for improved comfort. Bucket seats have a traveling inboard buckle that moves with the seat. An integrated child seat, like the one in the Chrysler minivans, is also available for the rear seat. Supplementing the seatbelt restraints is a dual airbag system consisting of a driver and a passenger side airbag. An airbag system diagnostic module contains the electronic circuits for the system. It's located under the instrument panel just below and behind the radio and heater controls. 2 impact sensors mounted to the headlamp carrier and a safing sensor inside the airbag module provide information on crash severity. In order for the airbags to activate, at least 1 impact sensor and a safing sensor must reach their set point. The airbags deploy within 1 millisecond of each other when the inflator assemblies receive an electrical signal from the airbag system diagnostic module. The airbag itself is a new ventless design. A porous weave on the uncoated back panel acts as a filter, minimizing the amount of smoke and particulates that escape when the airbag is activated. An airbag system readiness light in the instrument cluster illuminates for about 7 seconds when the ignition is turned on. The lamp also lights up to indicate that an airbag system fault exists. Concorde Intrepid and Vision airbags are diagnosed using the DRB2. We'll look at passive restraints in more detail in a future release, but now let's take a look at the powertrain.
The Concorde, Intrepid, and Vision are available with either a 3.3-liter V6 or a 3.5-liter V6. The engine is a north and south design, resulting in better weight distribution and packaging than a vehicle with an east-west mounted engine. The engine is mounted on a front cradle, which isolates engine vibration from the passenger compartment. 2 hydroelastic mounts support the engine in front, and an elastomeric rubber mount supports the engine transaxle assembly in the rear.
The 3.3-liter engine is an adaptation of the east-west design used in other Chrysler vehicles. a new lower profile intake manifold, new cylinder head covers, left and right exhaust manifolds, and modified engine block lead the list of engine modifications for the north-south version of the 3.3-liter engine.
The new 3.5-liter engine is a 24-valve overhead cam V6 rated at 214 horsepower at 5,800 RPM. It uses a cast iron cylinder block with a 60-degree bank angle and aluminum cylinder heads with a single overhead cam and 4 valves per cylinder. The aluminum intake manifold is a new low-profile cross-ram type with dual throttle bodies and sequential multi-port fuel injection. The intake manifold uses a manifold tuning valve to optimize intake manifold tuning. The valve is controlled by the powertrain control module through a solenoid mounted next to the canister purge solenoid. The engine uses Chrysler's distributorless ignition system. A poly V-belt drives the engine's accessories. A V-belt drives the air conditioning compressor. We'll have more on the 3.5-liter engine in an upcoming release. Now, let's move on to the vehicle's fuel system.
The 3.3 and 3.5-liter engines used in the Concorde, Intrepid, and Vision models are equipped with sequential multi-port fuel injection. The fuel tank is located in the rear of the vehicle, below the trunk. It's made of molded plastic and has a capacity of 18 gallons. The electric fuel pump module, which contains the pump and level sensor, is installed inside the fuel tank. The fuel filter is mounted on the passenger side inner frame rail near the fuel tank. Quick connect couplings are used to connect flexible fuel tubes to the fuel filter as well as to the plastic fuel tubes at the fuel tank. Steel fuel tubes run along the passenger side frame rail toward the front of the vehicle, where they are quick coupled to flexible fuel tubes that lead to the fuel rail. The flexible fuel tubes are also quick coupled to the fuel rail mounted on the cylinder head. The injectors and pressure regulator are mounted on the fuel rail. The 3.5-liter engine uses bottom feed injectors. A fuel rail housing made of thermoset plastic helps to control fuel temperature. The powertrain control module, located under the air cleaner assembly, regulates the fuel system using a number of sensors, switches, and relays. The 3.5-liter engine is calibrated to use mid-grade unleaded fuel. We'll be covering this fuel system in more detail in an upcoming release. Next, Kim will cover the cooling system.
The Concorde Intrepid and Vision cooling system has many advanced features. The radiator has an aluminum core and plastic side tanks, and there is no radiator pressure cap. A translucent de-aeration bottle located in front of the passenger side shock tower removes trapped air from the system. The de-aeration bottle contains the system's pressure cap. The pressure cap uses a spring-assisted vent valve that is new to Chrysler vehicles. The radiator hoses are made of a new material that lasts longer than hoses used in the past. Dual electric fans are controlled by the powertrain control module through the radiator fan relays. The fans operate at high or low speed depending on engine temperature and AC system pressure. The coolant capacity is 11.8 quarts. Cooling system components specific to the 3.5-liter engine will be covered in the 3.5-liter engine program. Now, Chuck will show you the exhaust system.
The exhaust systems on the Concorde, Intrepid, and Vision are made of stainless steel, but there are differences in exhaust components based on the engine and vehicle line. To control emissions, the 3.5-liter engine uses two small metallic close-coupled catalytic converters on each front exhaust pipe and a third main underfloor ceramic converter. This is the first high-volume use of converters, which use a coated metallic structure. The metal is coated with platinum and rhodium to convert the exhaust gases. The 3.3-liter engine gets only the main underfloor ceramic converter. After exiting the underfloor converter, the exhaust passes through a custom-designed rectangular muffler, which is designed to maximize muffler size within the space provided. Finally, there is a resonator at the rear of the vehicle. All vehicles with a 3.5-liter engine get a dual outlet resonator. Vehicles with 3.3-liter engines get a single outlet resonator. Computer analysis was used to develop an exhaust system that creates a balance between engine noise and back pressure, resulting in more horsepower while meeting noise and emissions requirements. Let's move on and take a look at the all-new Transaxle. The Concorde Intrepid and Vision use the new heavy-duty 42LE electronically controlled Transaxle. It's the only Transaxle available. The Transaxle is mounted north and south behind the engine. It has a cast aluminum case with a stamped steel oil pan. The Transaxle assembly uses 2 separate fluids and 2 oil sumps. The transmission uses transmission fluid. The differential uses gear lube. These fluids must never be mixed. The transfer shaft has 2 seals to separate the fluids, with a weep hole between the seals that will help you detect fluid leakage.
Some of the other unique features of the 42LE Transaxle can be seen with this cutaway. The solenoid assembly is attached to the valve body and submerged in transaxle fluid. This reduces the noise level and the chance of component contamination. The manual valve lever position sensor is also attached to the valve body inside the transaxle. The transaxle uses a transfer chain and 2 sprockets to transfer power from the output shaft to the transfer shaft, eliminating transfer gears and decreasing noise. A hypoid-type ring gear and pinion set allows the output shaft to cross the input shaft, making lengthwise mounting of the transaxle possible. The output speed sensor provides vehicle speed information, eliminating the vehicle speed sensor, speedometer, pinion, and associated wiring, and the output speed sensor is more accurate. An electronic shift indicator in the instrument panel is used to display the gear the transaxle is in. This information is obtained across the C2D bus from the transaxle control module, which obtains gear position information from the manual valve lever position sensor. The transaxle control module, or TCM, is located on the inside left fender behind the battery. The TCM regulates the operation of the transaxle using information from several inputs. A more detailed explanation of the new 42LE Transaxle will be provided in an upcoming release. Now, on to the suspension and steering system.
The Concorde Intrepid and Vision use one of 3 tuned suspensions, each with its own handling and ride characteristics. They are identified as Base, Touring, and Performance. The Concorde is available with the Base and Touring suspension. The Intrepid is available with all 3 suspensions. The Vision is available with the Touring and Performance suspension. The fully independent multi-link rear suspension consists of Chapman struts, lateral links, trailing arms, stabilizer bars, vertical links, and a crossmember. The rear suspension packages will vary in the struts, springs, crossmembers, and rearmost lateral links. Toe settings are adjusted using the rearmost lateral link. Rear suspension caster and camber angles are non-adjustable.
The front suspension uses McPherson struts, control arm assemblies with an integral ball joint, tension struts, stabilizer bars, a cradle, and vertical links. The front suspension packages will vary in the stabilizer bars and the struts used. Toe settings are adjusted at the tie rods. front suspension caster and camber angles are non-adjustable. The steering gear is provided by TRW, and it is a power rack and pinion type with center takeoff. There are 2 gears available, standard feel and firm feel. The power steering pump is located under the alternator, and it has a remote reservoir on the driver's side of the engine compartment near the battery. The vehicles have a 37-foot, 6-inch turning circle and are equipped with 15-inch or 16-inch wheels. The suspension and steering system will be covered in more detail in the second half of this release.
There are 4 brake systems available on the Concorde, Intrepid, and Vision. A front disc and rear drum system, 4-wheel disc brakes, 4-wheel disc anti-lock braking, and 4-wheel disc anti-lock braking with traction control. The front disc brakes use vented 15-inch rotors with a 60-millimeter piston bore. The rear disc brakes use 14-inch non-vented rotors with a 36-millimeter piston bore. A self-adjusting drum-and-hat parking brake is used with rear disc brakes. The rear drum brake is self-adjusting and contains the parking brake mechanism. The parking brake uses a push-to-release pedal mechanism. The anti-lock brake system is a Tevis design. Anti-lock brakes prevent wheel lockup under heavy braking conditions on any road surface. This is done by monitoring wheel speed, using wheel speed sensors at each wheel. The hydraulic unit for the anti-lock brake system is mounted in front of the master cylinder beneath the heat shield.
The hydraulic unit contains a number of components. They are the valve body, pump motor assembly, fluid reservoir, and proportioning valves. The anti-lock brake controller, or CAB, is attached to the valve body. Vehicles with anti-lock brakes use a brake warning lamp in the instrument cluster and an anti-lock warning lamp in the message center.
A traction control system is only available with anti-lock brakes. The traction control system reduces wheel slip and maintains traction at the driving wheels by engaging the brake of the wheel that is losing traction. The anti-lock brake sensors at each front wheel indicate wheel slip and send a signal to the special CAB with traction control circuitry. 2 extra isolation valves are added to the valve body. These valves close during traction control operation. The build and decay valves are then cycled to maintain maximum traction. Traction control operates at speeds below 25 miles per hour. It does not function above 25 miles per hour. There are 2 traction control lamps in the message center. The green traction control function lamp is on when the CAB is actively engaged in traction control. The amber traction control warning lamp is on when the system is deactivated. The system is deactivated when there is a fault in the traction control system or if the system is turned off manually. A switch located on the instrument panel can be used to manually turn the traction control feature off. The system defaults to active after each restart. Brake systems will be covered in more detail in the second half of this release.
The climate control system on the Concorde, Intrepid, and Vision is new to Chrysler vehicles. 3 different systems are available: heater only, manual AC, and automatic temperature control, also known as ATC. The 3 heating units are almost identical, the difference being the use of a blower motor resistor for the heater and manual AC systems versus a power module on units with automatic temperature control.
All climate control systems have electronic buttons and knobs with quiet and precise electronic actuators. In addition, the heated backglass control is on the climate control panel. The climate control ducting has some unique features. In addition to the instrument panel ducts, the ventilation ducts and demisters are routed through the instrument panel end caps and through the door trim panels. Ducts also route air to the rear of the vehicle. On 5-passenger vehicles, the duct runs through the center console. On 6-passenger vehicles, the duct runs under the carpet.
Electric motors are used in place of vacuum-actuated components to control the mode door, air inlet recirculation door, and blend air door. The body controller drives and monitors door position instead of a separate controller. Diagnostics and calibration of the mode and blend air doors are done using the control panel on manual systems. The DRB2 is used for diagnostic and calibration on ATC systems. The Concorde Intrepid and Vision AC system uses R134A type refrigerant. It is not compatible with R12 refrigerant. To avoid mixing the two refrigerants, the low side and high side service ports of the R134A system are different. You should also be aware that the high side service port is larger than the low side service port, which is the opposite of the R12 system. The body controller contains the climate control system circuitry. The climate control panel is only a user interface. The manual AC and automatic temperature control system also use the C2D bus communication link between the control panel, powertrain control module, and body control module to monitor and control the system. A new type of pressure transducer replaces the high pressure, low pressure, and temperature switches normally used on other AC systems. It is located in the AC discharge line. The pressure transducer provides this information to the powertrain control module, which controls operation of the AC clutch relay, low-speed fan relay, and high-speed fan relay. This is the first automotive AC system that can be checked electronically. Instead of using pressure gauges, system pressures are available using the DRB2. That's a quick look at the climate control system. Let's move on to a discussion of the electronic components on the Concorde Intrepid and Vision.
With one exception, all relays and fuses are mounted in 2 locations: the power distribution center and junction block. The heated backglass relay is located on the climate control panel. The power distribution center, or PDC, is located in the engine compartment behind the battery. It contains ISO relays, slow-blow cartridge fuses, and blade fuses. The junction block is located on the driver's end of the instrument panel. It contains blade fuses, relays, and circuit breakers. The IOD disconnect is now a fuse located in the junction block. A detailed list of fuses, relays, and circuit breakers is included in the reference book.
There are several control modules on the vehicles. The powertrain control module is located in the engine compartment under the air cleaner assembly. The ABS control module is attached to the hydraulic assembly in the engine compartment. The transmission control module is located in the engine compartment outside of the battery. The airbag system diagnostic module is located under the instrument panel on top of the center tunnel. The remote keyless entry module and flasher are located below the instrument panel top cover, just right of center. The body control module is located above the right side kick panel. There is a base and premium body control module. The premium body control module is used when the vehicle is equipped with automatic temperature control and the overhead travel information system. All of the control modules except for the remote keyless entry module are on the bus. The instrument cluster and overhead travel information system are also on the bus. The electronics on the Concorde, Intrepid, and Vision can be tested and diagnosed using the DRB2 and the Mopar diagnostic system. There is only one diagnostic connector on the Concorde, Intrepid, and Vision for all vehicle systems. It is located under the instrument panel above the accelerator pedal. That's a brief look at the major electrical system components.
We've introduced you to the Concorde, Intrepid, and Vision, and familiarized you with its features, systems, and components.
Extra care should be taken at the dealership to provide Concorde, Intrepid, and Vision owners with a quality product. This starts with a thorough pre-delivery inspection.
And it continues with quality service, which only can be provided by having a thorough knowledge of the vehicle's systems and components.
In the next few months, you will be provided with more in-depth information on these great new vehicles on videotape.
In addition, Chrysler Service Training can provide additional hands-on training at a Chrysler training center near you. The second part of this tape covers steering, suspension, and brakes. Welcome to the second part of the Chrysler Concorde, Dodge Intrepid, and Eagle Vision new model training programs. In the first program, we touched on some of the exciting features you're going to be seeing on these cars. Now, it's time to go into more detail in three of the areas: steering, suspension, and brakes. A major consideration in the design of Concorde, Intrepid, and Vision was providing outstanding handling and a comfortable ride. But instead of offering a single compromise between these two, the engineers decided to offer three distinct handling packages: base, touring, and performance, with base providing the most supple and performance the stiffest suspensions. Two different rack and pinion assemblies allow differences in steering feel. Besides creating vehicles that would accommodate different tastes in ride and handling, safety was another big consideration during the design stage, and it shows. The Tevis Mark IV anti-lock brake system is standard equipment on some vehicles and optional on all others. The system boasts individual build and decay valves for each wheel brake. An additional safety feature is the traction control option, available for the first time on a Chrysler vehicle. Many of the anti-lock brake components are also used for traction control. The system operates the brakes on the drive wheels to control slippage at speeds under 25 miles per hour. The base brake system also boasts some new features, such as the push-to-release parking brake. All of these features, and others we're going to discuss, combine to make the Concorde, Intrepid, and Vision real crowd pleasers. Now, let's take a closer look, starting with the steering. You'd expect power steering to be standard equipment on Concorde, Intrepid, and Vision, but you might not have expected a 5-position tilt column as standard equipment. The column uses rubber bumpers and a square spring for smoothness of operation. To prevent the effort that's sometimes needed to operate the lock cylinder, the steering wheel lock is designed to operate only after the wheel has been turned 180 degrees from the straight-ahead position. The column also houses a convenient multifunction stalk. My colleague here at the training center is standing by to fill you in on some of the service features of this new column. Greg?
Thanks, Chuck. Okay, there are several serviceable items on this column. At the base, the lower bracket and adapter can be replaced. At the top, the lock cylinder, multifunction switch assembly, and shifter are replaceable, as of course are the clock spring, airbag module, and steering wheel. On column shift steering columns, the interlock cassette can also be replaced. When replacing column assemblies, keep in mind that the tilt assembly springs for column shift and floor shift equipped vehicles are not the same, so the column assemblies are not the same. Also, keep in mind that clock spring replacement means using a procedure to lock the column. Otherwise, you could exceed the spring's travel limits. Can you think of anything else they should know, Chuck?
Just this. If you plan to remove the column, you're going to need to remove the lower dash panel, or knee blocker as it's sometimes referred to. You'll also need to lock the column to prevent damage to the clock spring. Refer to the service manual for details concerning steering column service. The steering column connects to a TRW rack and pinion steering gear. The steering gear ratio is 17:1, and the assembly uses a center takeoff design. As we said earlier, there are two racks available, a base version and a firm version, which provides more road feel. Show them how to tell the two apart, Greg.
Sure. There's an identification tag on top of the gear on the passenger side. The last 3 digits of the part number tell you which one it is. A standard feel gear has a different number at the end than a firm feel gear. And like other steering gears used on Chrysler vehicles, this one is serviced as a unit.
Thanks, Greg. For power assist, the steering gear uses a vane-type TC-style power steering pump. Oh, and by the way, TC stands for Transverse Compact. The pump's mounted here, under the alternator. The power steering system uses a remote reservoir mounted here, on the driver's side by the battery. The reservoir top has a dipstick built into it. Greg, do you have a few service items they need to keep in mind?
Sure do. One is very important. Use only Mopar power steering fluid in the system, not trans fluid. You can use the standard pressure test and bleeding procedure for the system. The pump itself is serviced as an assembly, but keep in mind there are special tools for removing the power steering pump from the shaft and for drawing the pulley onto the pump shaft. If you try to press the pulley on, you'll damage the power steering pump's internal components. Back to you, Chuck.
Okay, we've pretty much covered steering. Now, we need to move on to suspension. As we mentioned earlier, base, touring, and performance suspension packages are offered on the Concorde, Intrepid, and Vision, though all three are not necessarily offered on all 3 models. On the front suspension, the differences in suspension result from varying the stiffness of the parts used. No matter what the variation, though, the basic design of front suspension is the same for all models. Greg?
The Concorde, Intrepid, and Vision use a cradle, not only for supporting the engine and transaxle, but also to attach some of the suspension components. The cradle itself attaches to the chassis at 4 points. The inboard end of the lower control arm attaches to the cradle, as does the inboard end of the tension strut. The other end of the tension strut attaches to the outer end of the control arm. The lower control arm attaches to the steering knuckle with a ball joint. The lower end of the McPherson strut attaches to the steering knuckle, and the strut's upper end attaches to the vehicle body. A tie rod attaches to the strut to provide steering, and a sway bar attaches to the strut by means of a vertical link. The vertical link features a double ball joint design. For the most part, the suspension components are ones you've seen before.
And operation is the same, with the McPherson strut controlling up and down movement, the control arm providing lateral support, and the tension strut helping to control fore and aft movement. But when it comes to service, there are some differences you need to be aware of.
Right. For one thing, with the differences in suspension stiffness, parts are not interchangeable between one suspension type and another. For example, the sway bars and McPherson struts used in a performance suspension should not be used on a base suspension. For another thing, you'll need a new special tool to replace bushings in the lower control arm. As on other vehicles, you can adjust tow by backing off lock nuts and rotating the tie rod sleeve. but camber and caster are not adjustable. And you should never try to turn the lower strut mounting bolts since they're serrated and are not designed to turn.
By the way, just because camber and caster are not adjustable doesn't mean you don't have to check these alignment angles.
That's right, Chuck. A check of the alignment angles can reveal damage to components that a visual inspection might not. And if you do find that the tension strut needs to be replaced, keep in mind that the strut can only go in one way and its fasteners cannot be reused. Back to you, Chuck.
Okay, now let's move on to the rear suspension. The rear suspension on Concorde Intrepid and Vision does use a trailing arm and strut, but it also uses some other components you may not be used to seeing.
Like two lateral links per side, which connect to a cross member. These control the strut's inboard and outboard movement. To lessen deflection under load, the strut springs have a high spring rate. As on other suspensions, the trailing arm controls fore and aft movement. The hardness or softness of the bushings in the trailing arm and the lateral links helps to determine ride and handling. To limit body sway, the struts are connected to each other with a stabilizer bar. The bar connects to the struts by means of a vertical link, just as on the front.
And as on the front, camber and caster are not adjustable on the rear, but there is a spec for rear camber. Toe is adjustable. In fact, you'll need to check rear toe every time the suspension is disconnected, or you replace parts, but you'll need to be careful.
That's right, Chuck. You can adjust rear toe here at the sleeve in the rearmost lateral link. But be aware that when you're done, a minimum number of threads must remain engaged. The specification is in the service manual. The bushings on the rear are part of the assemblies and are not serviceable, and since they vary by suspension stiffness, you'll need to check the suspension type and parts application when replacing parts. The cross members are also not interchangeable, because the suspension package differences are due in part to the positioning of the lateral links on the cross member. Next, we're going to cover the basic brake system used on the Concorde, Intrepid, and Vision.
In this segment, we're going to look at the basic brake system components on the Concorde, Intrepid, and Vision. Later on, we'll examine additional components used for anti-lock brake and traction control operation. Let's start with the master cylinder. Two versions are used. Both versions split the brake system into two diagonal circuits during normal braking. The ABS version also splits the brake circuits diagonally during anti-lock braking. The one on non-ABS equipped vehicles uses conventional pistons and seals for the primary and secondary circuits. The master cylinders on vehicles with ABS use central steel valves instead of pistons and seals. The max fill mark is located here on the reservoir, as it is on non-ABS vehicles. Fluid level switches are used on both the ABS and non-ABS reservoirs. They turn on the red brake warning lamp to indicate low fluid level. Except for the reservoirs and grommets, both of these master cylinders are serviced as assemblies. The ABS and non-ABS reservoirs and grommets are not interchangeable, and neither are the master cylinders, so be sure to check the part numbers when replacing them. Power brakes are standard on the Concorde, Intrepid, and Vision, and like the master cylinders, the boosters come in two versions, one for vehicles without ABS and one for vehicles with ABS. You can easily identify the ABS vacuum booster by its pedal travel sensor. On non-ABS vehicles, proportioning valves come in two versions, one for vehicles with four-wheel disc brakes and one for those with front disc and rear drum brakes. ABS-equipped cars use two proportioning valves, one for each of the rear brake hydraulic circuits. These proportioning valves screw into the hydraulic control unit. These valves can be replaced separately, but they are not designed to be interchangeable. Now, let's join Greg, who will go over some of the features of the front and rear brake assemblies and the brake lines.
Thanks, Chuck. The front brake assembly is pretty straightforward. It uses a Kelsey-Hayes single piston sliding caliper. The brake pads are non-asbestos semi-metallic. The rotor is vented. An anti-rattle clip is part of the brake pad. Part of the clip is positioned to contact the rotor after the brake pads wear down, so the clip also serves as a wear indicator. You've probably seen the rear disc brake assembly before. The single piston sliding caliper and solid rotor is used on other Chrysler vehicles. The disc brake pads are made of an organic, non-asbestos material. The solid rotor is a drum-in-hat design to accommodate the parking brake. The rear drum brake used on some vehicles is the standard self-adjusting type. The parking brake on both the disc and drum rear brakes is activated by the new push-to-release parking brake mechanism. The brake engages by means of a ratchet mechanism and releases through spring-loaded linkage. When replacing brake lines on the system, keep in mind that the ends of the lines do not have the double flares you may be used to seeing. Instead, the brake lines on Concorde, Intrepid, and Vision use ISO-style tubing flares and connections. By the way, the rear hub contains 2 straight roller bearings which are serviced as part of the hub assembly. The front hub is hub unit 3, which you're probably used to seeing on other vehicles. It's serviced as an assembly. Chuck?
Let's not forget the wheels. There are 3 types available: steel, polycast, and aluminum, and they all use standard wheel weights and can be balanced on conventional equipment. If you've been working on brakes for a while, you've probably seen more and more vehicles equipped with anti-lock brakes. ABS has become an increasingly popular safety feature, and for good reason. On a slippery surface, when the brakes are applied to a wheel which is not controlled by ABS, the wheel can lock up. This results in 100% wheel slip as the wheel slides across the road surface. This amount of wheel slip reduces braking effectiveness and, more importantly, results in a loss of directional stability. On slippery surfaces, ABS limits wheel locking. For braking, some wheel slip is desirable. Zero wheel slip would mean that the wheel is rolling free. As a result, ABS is designed to maintain an average of 15 to 20% wheel slip. The main advantage of ABS is that by limiting wheel slip, ABS allows the driver to steer while braking. To limit wheel slip, ABS uses wheel speed sensors and tone wheels to generate wheel speed signals which are monitored by a controller. When a locking tendency is detected, the controller operates the valves in a hydraulic control unit as necessary to decrease, increase, and hold brake pressure. Here's how the valves work. The Tevis Mark IV system uses a build and decay valve for each wheel to control brake pressure. These valves are also referred to as inlet and outlet valves. For normal braking, the build valve is open and the decay valve is closed. Brake fluid flows to and from the wheel brake through the open build valve. When the controller detects a locking tendency at the wheel, it first sends power to the build valve solenoid. This closes the build valve to prevent any further increase in pressure to the wheel brake. To reduce pressure at the wheel brake, the controller will then send power to the decay valve solenoid. This opens the decay valve and fluid flows out of the brake back to the hydraulic control unit reservoir. Once wheel slip is no longer present, the controller will close the decay valve and open the build valve until wheel slip is in the desired range. Then, the controller will close the build valve and allow the decay to remain closed. This maintains pressure at the wheel brake. Once the ABS is no longer required, the controller opens the build valve to allow normal braking. Concorde Intrepid and Vision use a Tevis Mark IV anti-lock brake system. Unlike many other systems, Tevis Mark IV does not develop high pressure at all times. For normal braking, power assist is provided by a vacuum booster. The pump motor assembly operates only during anti-lock braking, when it replenishes the brake circuits with fluid. During anti-lock braking, the movement of the pedal travel sensor is what tells the controller to operate the pump motor assembly. Now that we've touched on the basic components of the system, let's see how they all work together to control a right front wheel that is slipping. When the wheel speed sensors indicate a locking tendency at the right front wheel, the controller first closes the build valve for that wheel to shut off the source of pressure to the wheel brake, the master cylinder. To decrease pressure further, the controller opens the decay valve, which returns fluid from that wheel brake to the hydraulic control unit reservoir. Once the wheel speed sensors indicate that wheel slip is no longer present, the controller closes the decay valve and opens the build valve to increase pressure until the wheel speed sensors indicate the desired amount of wheel slip is present. As the build valve allows brake fluid from the master cylinder to go to the wheel brake, the brake pedal moves towards the floor. As a result, the controller uses signals from the pedal travel sensor to turn the pump motor assembly on and off to replenish the brake circuit with fluid. With wheel slip at a desired level, the controller closes the build valve to maintain pressure at the wheel brake. Once the wheel speed sensor or brake switch indicates that ABS is no longer required, the controller opens the build valve to provide normal braking. All this helps drivers decelerate on slippery surfaces. But what about accelerating? The answer is traction control, an option on vehicles with ABS systems. The purpose of traction control is to prevent wheel slippage at speeds under 25 miles per hour. This not only aids traction, but directional stability as well. Tell them about the components, Greg.
The components for traction control have been incorporated into the ABS components. To control slip, the traction control system uses the tone wheels and wheel speed sensors on the drive wheels, a special ABS traction control controller, a hydraulic control unit with 2 additional valves, and the pump motor assembly. Here's how it works. The wheel speed sensors alert the controller that one or both of the drive wheels is spinning when the brakes are not applied. The controller closes the isolation valves to isolate the brakes on the front drive wheels from the rear brakes. The controller then closes the build valve to any drive wheel not spinning, so it will not receive fluid pressure when the controller activates the pump motor assembly. Since the build valve to the brake with the spinning wheel is open and its decay valve is closed, fluid pressure can engage the brake and slow the spinning wheel. This allows the differential to transmit power to the wheel and tire with traction. Once the controller no longer detects a wheel spin tendency, it interrupts pump operation and opens the decay valve to allow fluid to return to the hydraulic control unit reservoir, reducing pressure. The system will also interrupt traction control operation if the controller's timer indicates that the brake linings may be heating up. ABS and traction control do have some noticeable operating characteristics you'll need to tell your customers about. During anti-lock modulation, the customer will feel pulsing in the brake pedal. The pedal will move toward the floor as the decay valve allows fluid to leave the brake circuit and the circuit is repressurized via the brake pedal. When the pedal travel sensor alerts the controller of a low pedal, the controller activates the pump motor assembly and pressurizes the brake lines, pushing the pedal back up. So, during ABS operation, the pump motor assembly does not operate all the time, and the customer should be advised that it is normal to hear it during an ABS stop. Pump operation during traction control is different. The pump operates continuously and uses relief valves to limit pressure, so be sure to advise the customers of this fact. That's an overview of how ABS and traction control operate and what the customer can expect to hear and feel. Next, we're going to take a more detailed look at the location and function of ABS and traction control components.
Most of the ABS and traction control system is located right here in the engine compartment, under a cover on the driver's side. On the outboard side of the assembly is the controller. Two different models are used, one ABS only, and the other ABS and traction control. You can identify which is which by their tags. The ABS-only controller has a white tag. The ABS and traction control controller has a blue tag. The two controllers are not interchangeable. We've already mentioned a few of the controller's functions: monitoring wheel locking tendency and wheel spin, and operating the valves and pump to control these. But the controller also monitors system performance, including its own. It can monitor itself because it contains two microprocessors that compare data. If the data disagree, the controller knows that something is wrong. Based on what it finds in the system or in itself, the controller can shut down the system, operate the warning lamps for ABS and traction control, store diagnostic information, and interface with the DRB2 scan tool. ABS controller inputs include the wheel speed sensors, pedal travel sensor, pump motor rotation sensor, the fluid level switch in the hydraulic control unit reservoir, the anti-lock warning lamp circuit, the ignition switch, main relay voltage, and brake switch. On ABS traction control controllers, the traction control switch and brake pressure switch are additional inputs. The traction control switch shuts off traction control, allowing a customer to rock a vehicle that is stuck in mud or snow back and forth. Outputs include the valve solenoids in the hydraulic control unit, anti-lock warning lamp, main relay, pump motor relay, and red brake warning lamp. On controllers featuring traction control, outputs also include the traction control warning lamp and function lamp. On all controllers, the C2D bus is used as both an input and an output. As you probably know, wheel speed information is essential to proper ABS and traction control operation. So, before we move on to the hydraulic control unit, let's go to Greg, who is standing by with his input on sensors and tone wheels.
The front wheel sensor is mounted here, in the steering knuckle. The front tone wheel is part of the outer CV joint housing. The rear sensor is mounted on the rear brake support plate or caliper adapter. The tone wheel is part of the rear wheel hub. The wheel speed sensors are the magnetic type, using a magnetic core in a coil. The spaces and teeth in the tone wheel cut the coil's magnetic lines of force and generate an AC voltage that varies with speed. The voltage also varies with the air gap between the tone wheel and sensor. The closer the gap, the higher the voltage. The air gap is not adjustable, however, you can check it. The front gap should be in the range of 20 to 65 thousandths of an inch. The rear gap should be in the range of 18 to 48 thousandths of an inch. You can also check sensor resistance. It should be in the range of 950 to 1250 ohms. The front tone wheel is serviced as part of the outer CV joint housing. The rear tone wheel is serviced as part of the rear hub. Anything that affects wheel rotational speed will also affect speed sensor accuracy. So for proper ABS operation, it's important to have wheels that are all the same size and tires that not only match in size, but are also properly inflated. The controller will make allowances for the use of a mini spare when it finds that 3 speed sensor signals agree. Back to you, Chuck.
Okay, our next component is the hydraulic control unit, or HCU. The HCU contains a valve body, pump motor assembly, proportioning valves, fluid reservoir, and a fluid level switch. It's located under the heat shield next to the controller. The HCUs for ABS only and ABS and traction control are different. You can identify the traction control HCUs by the 2 extra lines and the fact that the valve body used for traction control is longer. Both ABS and ABS traction control valve bodies have 8 ABS valves, a build and decay valve for each wheel. The ABS traction control valve body has additional components. 2 isolation valves separate the front brakes from the rears during traction control. Since the pump runs continuously during traction control HCUs also have pressure relief valves to limit pressure, and a brake pressure switch lets the controller know when the brakes are applied. A signal from the brake pressure switch will either interrupt traction control or it will cause the controller not to initiate it in the first place. It's important not to mix ABS only and ABS traction control hydraulic control units and controllers. Doing so will cause the controller to set faults. Installing an ABS traction control controller on an ABS-only HCU will result in traction control valve number 1 and number 2 fault messages. Installing an ABS-only controller on an ABS traction control HCU will result in a fluid level not processable fault. Oh, by the way, if you do need to install a new controller on an HCU, you'll find a special electrical connection between the two. An integral terminal block on the controller mates with an integral block on the valve body. Take care to disengage the clip and tang when separating the controller from the HCU, or you will damage the terminal blocks. After the controller is reinstalled on the HCU, the 2 attaching bolts can be installed. The pump motor assembly is located above the valve body and is operated by the controller. The pump uses a cam to drive 2 spring-loaded pistons. Spring-loaded check balls serve as suction and pressure valves. The direct current motor, which powers the pump, has an integral rotation sensor, similar to a wheel speed sensor. The rotation sensor gives the controller a way to check pump operation. Attached to the pump motor assembly is the hydraulic control unit reservoir, which will supply brake fluid to the system in case the master cylinder reservoir is low. A fluid level switch on the reservoir will light the ABS and traction control warning lamps to indicate a low fluid level. The reservoir can be serviced separately from the rest of the HCU, which is serviced as a single unit. Earlier we discussed the master cylinders and vacuum boosters used on ABS and non-ABS equipped vehicles. We pointed out that the master cylinders are different for ABS and non-ABS vehicles, as are the reservoirs. We also pointed out that the vacuum booster on ABS-equipped vehicles has a pedal travel sensor, so ABS and non-ABS boosters are not interchangeable. The pedal travel sensor is what's called a linear step transducer. Put simply, the sensor translates pedal movement into 7 distinct steps, and in this way lets the controller know about pedal position. Once anti-lock operation begins, the controller will activate the pump motor when the pedal travel sensor indicates an increase of 1 step. When the pedal is back to its original position, the controller will shut off the pump motor. By the way, if you do need to remove the sensor, be sure to bleed off the vacuum in the reservoir before doing so. Otherwise, this little O-ring could get sucked into the booster. Greg is standing by inside a vehicle to point out 2 other inputs to the controller.
Right, Chuck. Now, one's the traction control switch, which allows the driver to turn the traction control function off. It's located to the right of the steering column. Keep in mind that it's a momentary contact switch that only works with the key on. So how do you know what the traction control status is? Just look at the traction control warning lamp in the message center. If it's lit, traction control is not available. Concerning switch operation, also keep in mind that in normal operation, when the key is turned on, traction control becomes available no matter what its status when the key was turned off. Now, while we're here, we need to look at another switch used as an input for ABS. The brake switch is located above the brake pedal. The controller uses the brake switch to sense when braking is occurring. Of course, if the system isn't powered up in the first place, it doesn't make any difference what the inputs are doing. So before we get any further, we need to talk about fuses and relays. 3 of the fuses are located in the junction block on the end of the instrument panel on the driver's side. Fuse 6 is the ignition feed to the main relay coil and to the controller. We'll talk more about its job in a minute. Fuse 14 feeds the ABS warning lamp and traction control warning and function lamps. Fuse 17 feeds the red brake warning lamp. These fuses serve as feeds to other systems. Be sure to familiarize yourself with these other functions, since it will give you a better idea of related symptoms in your troubleshooting. Now let's go back to Chuck, who will tell you about the other fuses and system relays.
The remaining 2 fuses for ABS and traction control are located in the Power Distribution Center. Fuse H is the system feed, and Fuse F is the pump circuit feed. These fuses supply power to 2 relays, mounted on the outside of the PDC, the main relay and the pump motor relay. The main relay coil receives a feed from Fuse 6 when the ignition is turned on and is grounded by the controller. The closing of the relay contacts supplies battery voltage to the controller, ABS and traction control solenoids, and to the pump motor relay coil. Should the main relay coil become de-energized, the relay contacts will provide a ground to the ABS warning lamp, causing it to illuminate. The operation of the pump motor relay coil is simpler. The pump motor relay coil receives a feed from the main relay and is grounded by the controller when it needs to operate the pump motor. We've mentioned that the ABS warning lamp illuminates in the event the main relay coil is de-energized. That's not the only time it illuminates, and it's not the only lamp you need to know about. Greg's standing by with the lowdown on the lamps.
There are 4 lamps connected with the brake, ABS, and traction control operation. The amber ABS and traction control warning lamps are located in the message center, as is the green traction control function lamp. The red brake warning lamp is located in the instrument panel cluster. At key on, all of the lamps in the message center are illuminated by the controller for about 2 seconds during the system self-check. The controller also lights the amber anti-lock warning lamp in the event of an ABS malfunction and during an undervoltage condition. The controller will flash the ABS warning lamp when the system is placed in the diagnostic mode with the DRB2 scan tool. As explained earlier, a de-energized main relay also results in the ABS warning lamp illuminating. So a lack of power in the main relay coil, or the lack of a ground from the controller, will cause the lamp to illuminate. The illumination of the traction control warning lamp is dependent on the controller. Besides the key-on check, the controller illuminates the traction control warning lamp to indicate a malfunction, which is disabling traction control. The controller also illuminates the lamp to indicate that the driver has turned the traction control system off. Finally, the controller will illuminate the lamp when a fault occurs in ABS, and, as a result, the controller checks the ABS warning lamp circuit and finds it has failed. The green traction control lamp is a function lamp. Other than at key on, its illumination merely indicates that the traction control system is actively controlling wheel slip. Unlike the lamps we've just looked at, the red brake warning lamp does not illuminate in the on position. Instead, it illuminates as long as the key is in crank because it receives both power and ground from the ignition switch. Besides being illuminated in crank, the red brake warning lamp is also illuminated by the parking brake when it is applied. The fluid level switch in the master cylinder reservoir will also illuminate the lamp in case of low fluid level. The controller illuminates the lamp if the pedal travel sensor indicates that a failure in the base braking system has occurred. In addition, the controller illuminates the lamp when a fault occurs in the system, and as a result, the controller checks the ABS warning lamp circuit and finds it has failed,
When the system is placed in a diagnostic mode with the DRB2, the controller will cause the lamp to flash. If the problem at key on is merely that the ABS lamp circuit has failed, the controller will not illuminate the red brake warning or traction control warning lamps, but it will set an ABS warning lamp fault. In examining the warning lamps, we've talked a little about the controller's diagnostic capabilities and the setting of faults. In the next segment, Chuck's going to explain these two areas in greater detail.
One feature of traction control diagnostics relies on the controller's ability to check itself. As mentioned earlier, ABS controllers contain two microprocessors that receive and process data from ABS inputs and then compare the results. Should the results disagree, the controller will shut down the ABS and traction control, light the ABS and traction control warning lamps, and set a fault. The only way to get rid of this fault is by replacing the controller. Besides checking itself, the controller checks system components. This check occurs during key-on, when it tests all the electrical components of the system, and when a vehicle first reaches a speed of 5 to 10 miles per hour, referred to as a dynamic test. During this dynamic test, the controller cycles all valves and runs the pump motor. A driver who has a foot on the brake pedal may feel the dynamic test being run. If the controller detects a malfunction during either of its self-checks, it will set a fault. The type of fault depends on the nature of the malfunction. If the fault is non-latching, ABS and traction control are disabled until the fault goes away, and the amber ABS and traction control warning lamps are lit as long as the malfunction exists. The only non-latching fault is caused by an open in the HCU reservoir's fluid level switch. Another type of fault, the locked fault, will cause the controller to disable the ABS and traction control and illuminate the ABS and traction control warning lamps. The lamps will remain lit and the systems will remain disabled until the problem is repaired and the fault is erased using the DRB2 scan tool. Hydraulic failure, as detected through the pedal travel sensor, is the only locked fault. All other malfunctions result in a latching fault being set. Latching faults also disable ABS and traction control. Even if the faults go away, the systems remain disabled until the next key-on. Similarly, both ABS and traction control warning lamps are illuminated until the next key-on, even if the faults go away. You can retrieve all of these faults using the DRB2 scan tool or the Mopar diagnostic system. The diagnostic connector is located to the right of the steering column above the accelerator pedal. But you can do a lot more with the DRB2 than read faults. Greg's standing by to point out some of the DRB2's other capabilities.
Right. When it comes to troubleshooting the ABS and traction control system, there's no substitute for the DRB2. Remember those wheel speed sensor inputs? You can access them with the DRB2 when vehicle speed is below 10 miles per hour. They'll read out in miles per hour. If you lift the car to obtain the wheel speed sensor readings, be sure to turn the traction control system off on vehicles with this option. Running a car with traction control with the wheels off the ground makes the controller think that the front wheels are spinning. With the DRB2, you can also read input states of the brake switch, traction control switch, pressure switch, HCU fluid level sensor, and rotation or motor sensor. The DRB2 can also tell you which step the pedal travel sensor is on. In fact, when you install a new sensor, you'll need to use the DRB2 to confirm that the sensor is operating properly. Part of the pedal travel sensor test involves actuating outputs, another capability of the DRB2 that is available if the car is not going more than 5 miles per hour. Outputs include the build and decay valves for each wheel, the pump motor, and on vehicles with traction control, the isolation valves and traction control warning and function lamps. As with other anti-lock brake systems, the DRB2 is also used for brake bleeding of the Tevis Mark IV system. You'll need to do a conventional bleed first, then a bleed with the DRB2 scan tool, and then another conventional brake bleed.
Thanks, Greg. Well, that's about it for this month's programs. Be sure to check your course selection guide for courses related to the Concorde, Intrepid, and Vision.
And tune in to the next release, which covers the 42 LE Transaxle and passive restraint system.